All right, everybody, got another problem. So this one we're dealing with integration. Just integrating some problems, not even in the context of physics. Integration is super important, um, and I feel like it takes a while to really get used to it, to be honest. But once you get in the groove of it, you start to pick up some techniques and some intuition. Um, but the only way to get good at it is to do problems, problems, problems. So let's jump right in. So we have the first one, A, is the integral of cosine of x squared times 2x dx. Okay, and we're evaluating this from 2 to 6. So, um, one of our techniques for more complicated integrals is that u sub. And remember, I think the trick really there is if you see a term in your integral where the derivative of that term is somewhere else in that integral, then that's a red flag. So for example, for this one, I see this x squared. Derivative of x squared is 2x. So this is very suggestive that I should do u sub. Okay, so if I let we're creating a new variable, let u equal x squared, then du by dx equals 2x. So du equals 2x dx. Okay, we kind of treat these things like a fraction. And I just bring that dx over here. And then what do we see? This 2x dx is in my integral. So now I can do the integral from 2 to 6 of the cosine of x squared, and then I have 2x dx right here, so I'll just plug in du. So this is the integral of cosine of u du. Now we know how to integrate this. Integral of cosine is sine. Okay? So now we plug back in what our u is, sine of x squared, and we evaluate it from 2 to 6. So you'll get the sine of 6 squared minus the sine of 2 squared. And if you're in degrees, you will get sine of 6 squared minus the sine of 2 squared. So sine of 36 minus the sine of 4 equals about 0.52. So that's our first one. We did u sub because one of our terms had a derivative that looked like it was somewhere else in the integral. Okay. Now we want to do part B. Part B is the integral of the cosine of x times the sine of x dx. Now the derivative of sine is cosine, right? So once again, this is suggestive. Let u equal the sine of x, then du equals cosine of x dx, using our same trick from above. So now I have the integral of u times du, which you know how to integrate this. This equals u squared over 2. Plugging in u, I get the sine of x squared all over 2. And this one we're evaluating from 0 to 1. So I'll go from 0 to 1 right here. Sine of 0 is 0. So this will be the sine of 1 squared all over 2. Okay. So once again, we saw that red flag. We saw that one of my terms, if I could take a derivative of it, is somewhere else in there, and that's the signal. Okay. So now I want to do integral from a to b of e to the 5x plus 7. Now this one you might be able to guess what it is. I can even write this a little more suggestively. A to b, and then I can factor out these guys. Remember, if exponents are added together, then that is the same as multiplying the exponents. Okay. So this will equal e to the 7th, and then integrating this e to the 5x, I will get 1 over 5 e to the 5x evaluated from a to b. So we'll get e to the 7th over 5 e to the 5b minus e to the 5a. Without knowing b and a, we can't go any farther past that. Then the last one, we are integrating 1 over y dy from 2 to x. Integral of 1 over something is the natural log of that something. So I'll get the natural log of y evaluated from 2 to x. This equals the natural log of x minus the natural log of 2. And there's a useful log law. If you have two logs that are subtracted like this, then that is the same thing as 1 log of the quotient between the two, dividing the two. Okay. So either of these two would be totally correct as your right answer. So let me zoom out so you can see the whole problem. Okay. So it's just another integration technique. Use substitution is kind of the big one here. But we can do some kind of elementary ones too by just kind of moving some things around. Okay. So I hope that was clear, and that's the end of the problem. And let me box this answer right here. Yep. So that's it.